This video is u sub with boundaries. So that means we're looking at it over an interval. Let's look at number 54. It says the integration from 0 to 1 of 3t minus 1 to the 50th dt. Now there's two ways to do this. The easiest way is used probably the most. So we're going to do u sub like normal. Let's let u equal 3t minus 1. Then du is 3 dt. So dt is 1/3 du. So we have the integration of u to the 50th times 1/3 du from 0 to 1. We keep the same bounds because we're going to do exactly what we did before. I'm going to pull my 1/3 out front. U to the 50th du. So we're going to integrate, and this becomes u to the 51st. We have 1 over 51, and we have a 1/3 out front. And now the bounds are from 0 to 1. So we have 1 over 153, and u is 3t minus 1 to the 51st from 0 to 1. So here's the difference. Now that you're completely finished with the u sub, and you put back in your variable of t, now you do the bounds. So you integrate with respect to 1. So we say 1 over 153 times 3 times 1 minus 1 to the 51st minus 1 over 153 times 3 times 0 minus 1 to the 51st. So we have 1 over 153. 3 times 1 is 3, minus 1 is 2. So we have times 2 to the 51st. Minus 1 over 153. And then have 0 and have negative 1 to the 51st. So I have 1 over 153 times 2 to the 51st. And negative 1 to the 51st is negative, so this becomes plus 1 over 153. I would factor out a 153, 1 over 153, so this will be 2 to the 51st plus 1. That's probably your best answer. 2 to the 51st is very large, so this is probably the most common way that u sub with boundaries is taught, because you already get to hear very well, hopefully. So then just to put in the bounds and evaluate is not difficult. There is a second way to do it. I'd like for you to at least see it. I don't care which way you use. We're going to look at the same problem from 0 to 1. And we have 3t minus 1 to the 50th dt. So we're going to let u equal 3t minus 1, and du equals 3 dt, and dt equals 1/3 du. Now here's the difference. Because we changed everything to u, we're going to consider t equals 0. Then we're going to put that in for u. So u equals 3 times 0. That's a times minus 1, which is negative 1. And when t equals 1, then u becomes 3 times 1 minus 1, and that's 2. So right here you change your bounds from negative 1 to 2, and we have u to the 50th. And then du, or dt, becomes 1 over 3 du. So the difference in this, we're going to pull our 1/3 out front again. The difference in this is we've done the method called changing the bounds. So our bounds are now in terms of u, so we don't go back to x. There are advantages both ways. The first method is the method I'm going to use. That's what most students do well because they already understand u sub. So this method you may use, and you can ask me about it if you have problems. You integrate this, and we have 1/3 times, now the integration is u to the 51st, so it's 1 over 51 from -1 to 2. Now those bounds don't match the original bounds in the problem, so we know we did them in terms of u. So we have 1 over 153, and then we have u to the 51st. I'm going to bring it down again from -1 to 2. So I have 1 over 153 times 2 to the 51st minus 1 over 153 times -1 to the 51st. So I have 1 over 153 times 2 to the 51st plus 1 over 153. So you can see I'm going to factor out my 153 again. It doesn't look like 153. There we go. 153, 2 to the 51st plus 1. So you can see it's the same answer either way. Most students find this method easier because all you do is evaluate at the end rather than changing bounds in the middle. You can go either way, whichever you would like to do. I'm going to show this first method as I continue the video. I'm going to do one more for you because you already understand u sub. Oh, there's one more I really want you to see. So let me find that one and then we'll do it. Okay, so this is number 69. So we have the integration from e to the 4th dx over x square root of ln of x. Now we always write ln of x with a cursive because otherwise it looks like the capital word N. We always write logs with a cursive L because otherwise it might end up looking like 10g or 10 grams at some point. So cursive L's are important in those cases. All right, I'm going to rewrite the problem first of all because most students and I like it better with the dx out to the side. So we're going to put 1 over x square root of ln of x dx. So we're going to let u equal ln of x. So du equals 1 over x dx. See how nicely that's going to be? Sometimes you have to pick a u and play with the du. The important thing to remember is that when you get ready to integrate, everything has to be in terms of u. There can be no x's. So if it didn't work out nicely, something is wrong. So let's solve for dx. Dx equals x du. Oh, that's going to be nice. I call it pretty math. Do you see the pretty in the math? So we're going to do the integration from e to the 4th. And I have 1 over x u to the 1/2 times x du. These x's cancel. So that means we have the integration from e to the 4th. This 1 over u to the 1/2, we're going to rewrite it as u to the -1/2 du because that's in the form to be able to integrate. So when we integrate, we add 1. This becomes u to the positive 1/2. And the reciprocal is 2 from e to the 4th. Now this is a monomial, but if it was more terms, you would need a parentheses saying that this evaluation bar right here, that it applies all the way, including everything in the parentheses. When you have a monomial, you don't have to have the parentheses. It's all one term, so it's good. You can go either way on that. So we have 2. Now our u is ln of x. And we're going from e to the 4th. So we have 2 ln of e to the 4th minus 2 ln of e. Now remember this 4 can move down here by laws of logarithms, properties of logarithms. And then ln of e is the number 1. So we have 8 minus ln of e is the number 1, 2. So this gives us a total of 6. So if you're good, I think that's all you really need because it's just adding bounds. If you're good, that's fabulous. If you need some more, if you let me know, I would be happy to do them. And thank you very much.